Jain friends, in today's lecture number 4, we will discuss symbol table and its implementation. Myself Sachin Jain, Assistant Professor at AKGEC Engineering College. So this is the outline of today's lecture. We will discuss symbol table. We will discuss usage of symbol table. We will discuss the information used by the compiler from symbol table, implementation of symbol table, operations of symbol table, and storage location of symbol table. So this is the outline of today's lecture. So what is symbol table? Symbol table is an important data structure that is created and maintained by the compiler in order to keep track of semantics of the variables. So just to keep track on the semantics of variables of a program, corresponding program, we maintain a record structure called as a symbol table. And symbol table stores the information about the scope and binding information. What is stored? Store the scope information and binding information about the name, information, instances of various entities such as variable and function name, classes, objects, etc. So all the information are stored in a record structure called as a symbol table. It is built-in lexical and syntax analysis phase, and this information is collected by the analysis phase of the compiler, and it is used by the synthesis phase. So in analysis phase, we will collect this information, and synthesis phase will use this information for generation of the target code. It is used by the compiler to achieve the compile time efficiency. So compile time efficiency can be achieved using this symbol table. So in every phase of the compiler, we require some information, and that information is stored in the symbol table. So what is the usage of symbol table? As I told you that every phase of a compiler access this information. So there are 6 phases of the compiler: lexical analysis, syntax analysis, semantic analysis, intermediate code, code optimization, target code. And every phase of the compiler access this information that is stored in the symbol table. So lexical analysis create a new table entries in the table about the token. Syntax analysis add information regarding attribute type, scope, dimension, line of references, etc. in this table. Semantic phase use further this available information in the table just to check the semantics is right or wrong, or just verify the expression assignment and semantic whether they are semantically correct or not. If not, then updation of symbol table can also be done with the semantic analysis. Intermediate code generation refers to the symbol table for knowing how much and what type of runtime is allocated, and the table helps in adding temporary variables of the information. So temporary variables can also be added in intermediate code, and the table can refer for knowing how much and what type of runtime is allocated, and further, if there is some modification required, then adding of temporary variable can also be done with the help of this page. So code optimization, it uses the information present in the symbol table for machine dependent optimization. So machine dependent optimization required some information that can be accessed through this symbol table. And the target code generation phase generate the code by using the address information that is actually stored in the symbol table. So target code can be generated further with the help of symbol table. So each and every field access this symbol table, and symbol table is connected with all the phases of compiler design, and this information is required when we are converting a high level language into the machine level language code, or you can say one type of code to another type of code. So what is the information that a compiler used from the symbol table? So as I told you that data type and name information is stored in the symbol table. So further, this information is used by the compiler, declaring procedures. This information can be used by the compiler. Offset in storage, and if structure or record, then pointer of the structure table. This information is required. This information can be used for parameters, whether parameters are passing by value or passing by the reference. This information can be accessed by the compiler from symbol table. Numbers and type argument passed to the function, how many number of arguments are passed to the function, or what are the type of argument. This information can be accessed from the symbol table, and base address information can also be accessed from the symbol table. So to implement the symbol table, we required 4 type of data structure that through which we can make a symbol table. So if a compiler is to handle a small amount of data, then symbol table can be implemented with the help of unordered list, which is easy to code, but it is only suitable for a small table only. If we required to store large amount of data, then symbol table can further be implemented with the help of these 4 type of data structure: list, linked list, binary search tree, and a hash table. So what is list? In this method, an array is used to store the information about the names and related information. So we will use the array when we want to implement symbol table with the help of list, and a pointer that name is available is maintained at the end of all the stored record, and new names are added in order as they arrive. So the pointer available will help us about to know the new information that will be stored in the symbol table. As to search a name in a symbol table, we can start from the beginning of the list and till the available pointer, and if it is not found, then we can get an error, use of undeclared name. So if you want to find a name in the symbol table, then we can further use this available pointer, and if this value is not stored in the table, then use of undeclared name, this error will be displayed. While inserting a new name, we must ensure that it is not already present, otherwise the error will be multiple defined names. So in this way, list works for symbol table. Another type of data structure that we use for storing the information in the symbol table, that is linked list. So implementation of symbol table using the linked list can also be done. A link field is added to each record. Here is a field called as a link. Link field will be added in every record of the symbol table, and searching of the name will be done with the help of this link pointer. So in the list, there was a pointer called available. Here is a pointer called link that will help us to access the information that is stored in the symbol table. And a pointer first also be used in the linked list that will maintain the point of first record of the symbol table. And the complexity of this insertion into the symbol table is first order of 1, but lookup of a name inside the symbol table takes a uh, large time, that can be order of n, as an average, in an average case. So there is two pointer, link pointer and the first pointer. Link pointer will add a record and first pointer will tell you what is the first record. Hash table. Another type of data structure is hash table. In hashing scheme, two tables are maintained, a hash table and a symbol table. That are mostly commonly used method. This is the commonly used method to implement the symbol table. And symbol hash table is basically an array with the index range from 0 to size of table -1. And these entries are pointer pointing to the name of the symbol table. And to search a name in the symbol table, we use the hash function, and that will result the integer between the 0 and size of the table -1. And insertion and lookup here is fast, that is with the complexity of order of 1. That's why the lookup is fast. That's why we generally use hash table to implement the symbol table. And the advantage of hash table is that we can quickly search a position, and disadvantage of this hash table is that it is complicated to implement. So this is the advantage and disadvantage of hash table. Now next type of record structure that is used to store data structure, that is used to make a symbol table, is binary search tree. So in this approach we use a binary search tree with the two link fields called as a left link and right link, or you can say left child or a right child. So in this way we can store the information left child, right child, and all names are created as a child of the root node. That is always follow the property of binary search tree. So binary search tree property will be followed when we are storing our information in a symbol table. And here the complexity of binary search tree is order of log base 2n, and an average case for insertion operation as well as lookup operation. So these are the common operations that can be performed on a symbol table. One is allocate, free, lookup, insert, set attribute, and get attribute. Allocate means to allocate a new empty symbol table. Free means to free all the entries from the symbol table. Lookup means we are searching a name and it return a pointer to its entry. And insert means we are inserting some information in the symbol table. Set attribute means we are setting an attribute value corresponding to the name, and get attribute to get an attribute associated with the given entry name. So these are the common operations that can be performed on symbol table. So out of these, two important operations are insertion and lookup. Insertion means inserting a value into the symbol table. Lookup means looking the value from the symbol table. So insertion operation is generally most frequently used in operation that can be accessed throughout all the phases of the compiler. So it is used to insert the information of the symbol, but it is generally used in analysis phase. Analysis and synthesis, there are two phases of the compiler. So analysis phase generally inserts value, and lookup generally used by the synthesis phase. So in this source code, an attribute symbol of the information associated with that symbol table uh, and the information contains the state, value, type, and scope about the symbol table. It is stored in the symbol table with this operation called insert. So the example of this operation is like this. Here X is the entry that we want to enter in the symbol table, and integer is the type of the value that is stored in the table. Lookup operation means we are looking a value, or you can say name, in the symbol table, and it is used to determine the existence of the symbol table, whether it is present or not, the creation of the symbol table before it is used, whether the name is used in the scope or not, initialization of the symbol, and checking whether the name is declared multiple times or not, or the basic format of lookup is to follow like this: lookup and the symbol that we want to check that is present on the symbol table or not. So these are the two common operations that can be performed on a symbol table. Now next is storage allocation. So memory allocation of a symbol table can be done with the help of three: static storage allocation, stack storage allocation, heap storage allocation. So what are the difference between these three? In static allocation, names are bound with the storage location. If a memory is created at a compile time, then memory will be created in the static area only once. So then if I want to allocate memory to the symbol table with the help of storage allocation, then memory will be allocated only once. Static allocation supports the dynamic data structure. That means memory is created only at a compile time and deallocated after the program completion. So in static allocation, we can store the information about the dynamic data. That means memory will be allocated at a compile time and deallocated when program compilation is over. But the drawback of this static allocation is that the size and position of data objects should be known at the compile time. So we should know the size and position of the data. What time? At compile time. Then we can store the information of the symbol table. And another drawback of this static allocation is that restriction of the recursion procedure. There is some restriction of the recursion procedure when we are doing static storage allocation. So these are the two disadvantages of this static storage allocation. Another thing that are possible with this static storage allocation is that storage is another type of storage allocation is stack based allocation. In static allocation, storage is organized as a stack as well. That is called as a stack storage allocation. So basically it is the enhancement of static allocation where we store the information in the form of stack. Activation record corresponding to the procedure is pushed into the stack whenever activation begins, and it is pop-up when activation ends. When a procedure is activated, then the information about that procedure is pushed into the stack, and when activation is done, then that information is pop out from this stack. Activation record contains the local, so that they are bound to the fresh storage and each activation record, and the value of locals is deleted when activation done, and it works on the basis of last in first out manner, and this allocation supports the recursion process. That is not possible with the simple static allocation scheme. Another type of allocation scheme is heap based allocation. Heap allocation is the most flexible and reliable scheme for storage allocation of a symbol table, and here allocation and delocation of memory can be done at any time. So there is no boundation of compile time or run time. At any time you can store, you can allocate the memory to the names or variables of a symbol table, and at any place depending upon the user requirement. So this is the main disadvantage of this heap based allocation scheme, and generally we use this scheme because it supports dynamic allocation of a memory. Heap allocation is used to allocate memory to the variable dynamically, and when the variables are no more used, then it claim it back. So this is the main advantage of heap based allocation. And heap based allocation also supports the recursion process that is not possible with the static allocation. So these are the three types of allocation scheme for storage allocation: static, stack, and heap. Static allocation, the problem is recursion is not possible, and we require to know in advance what is the size and position of the data objects. Stack based allocation, here recursion process supports, and in heap based allocation recursion supports, and we can allocate the memory at runtime. So that's all from my side. Thank you.